Hi all, let me explain how simple text generation pipeline using TensorFlow and Keras with a recurrent neural network RNN. I will explain step by step perform test case generation. First step, I will import required libraries. These are the libraries required to test case generation. I will explain how these libraries will perform the test case generation. First, TensorFlow and Keras. It used to build and train the RNN model. Next, importing tokenizer. It used to convert text into the sequence of numerical tokens. Next, paired sequences. It used to ensure all the sequences have the same length. And finally, pickle. It used to save and load the tokenizer object. These are the libraries we have used in text case generation. Next, defining example data. Here we can provide input and output text. These are the input and output text. If I provide a prompt for cat, we require the answer for this is a cat. Input text, it is simple single word input. For example, I have to provide animal names. Uh, Output is a sentence describing those animals. Next, tokenizing the text. We need to create a tokenizer instance. Uh, it learns a word index from both input text and output text. The word index maps each unique word to the numerical tokens. For example, uh, input text, we provide input text as cat. Each word set a set a index. For example, C have zero index, A have one index, T have two index. That as like indexing each word input or output text. Next step, saving tokenizer. Saves the tokenizer object to the file tokenizer.pickle using pickle. Once we have uh, indexing the input and output text, the tokenizer.pickle file will be created. This allows tokenizer to be reused later without retaining. Mm, we are not training each and every input and output text. Once we have created this file, it automatically reuses it without retraining. Next step, converting text to sequence. input sequence and output sequence. It converts word into the numerical sequence. For example, tokenizer dot word index. I will provide some examples. Convert this example for indexing the word into the numerical sequence. Input sequence, output sequence. Next step, padding the sequences. Here we can find the longest sequence length, maximum length to ensure all sequences are of equal length. We can provide input data and output data in batch sequence. Here, ensure that all sequences have the same length by adding zeros post padding. For example, input sequence and output sequence. Next, building the RNN model. Is the code to build the RNN model. Uh, this code will convert word index into the 50 decimal dense vector. We can provide the output team as 50. Next, it basic recurrent layer with 100 units. Keep output for each time step returning sequence of it will be uh, trained 100 times. Every time trying to last the word. Dense layer, a soft layer that predict the next word index. Next step, compiling the model. This is a line to use the compiling the word. It uses Adam optimizing for training, uses pair category as a loss function since the output is characteristical. Next, finally, is train the model. This is a line to use to train the model. Train the model is 100 epochs. It means input and output will train 100 times used padding input and output data. Next, saving the model. This line used to save the trained model in the save model format. Next, lo- let's load the save model. It used to reload the save model. We we never train each and every time we never use it to save and load it in this line use it to load the save models. Next, generating new text. In bad, it's converted into the tokenizer form. For example, if bad have a tokenizer is 6, they will provide the input sequence as 6. Next, next line has a input sequence and predict sequence. In predict sequence used to train a model to predict the output sequence. Finally, predicted text. It used to find the index of highest probability word at each time step. It convert indicates back to word, remove padding. Example output as bad is this is a bad. That's all. This is it's used to train a simple text generation model. Thank you.